A very good morning, sir. So this meeting is for the DA of my subject Network and Communication with the subject code CSE 1004. So the topic of my DA which I have chosen is Token Bus, which is the IEEE 802.4 standard. This is presented by me, Yuvraj Dutt Bajpai, 20 BCE 1523. So let's start with what is IEEE standards? The Institute of Electrical and Electronics Engineering Standards Association, that is also known as IEEE SA, is an operating unit within IEEE that develops global standards in a broad range of industries, including power and energy, artificial intelligence systems, Internet of Things, consumer technology, and consumer electronics, along with biomedical and healthcare, learning technology, information technology, and robotics, telecommunication and home automation, automotive, transportation, home automation, nanotechnology, information assurance, emerging technology, and many more. So, what is token bus? Token bus is IEEE 802.4 is a standard for implementing token ring over the virtual rings in LANs. LANs are the local area network. The physical media has a bus or a tree topology and uses coaxial cables. A virtual ring is created with nodes, also known as stations, and the token is passed from one node to the next in a sequence along this virtual ring. Each node knows the address of its preceding station and its succeeding station. A station can only transmit data when it has a token. The working principle of the token bus is similar to the token ring. So, here, let me shift it over here. Okay. So the given diagram shows a logical ring formed in a bus based token passing line. The logical ring is shown with the arrows. So like here we can see that there is a main line of network. Main line of network and many stations are connected to it like station 1, station 2, station 3, station 4, station 5. So these all stations are connected to a main line of network. This is known as the bus based on token. Okay, so the token, so there's some another definition of token bus with me. So token bus, that is IEEE 802.4, is a popular standard for the token passing LANs. In a token bus LAN, the physical media is a bus or a tree, and a logical ring is created using coaxial cable. The token is passed from one user to another in a sequence, either clockwise or anti-clockwise. Each station knows the address of the station to its left and right, like it was in the previous slide, its preceding and its successor. A station can only transmit data when it has the token. The working of token bus is somewhat similar to token ring, as it was stated earlier. So there are some points which I've briefed about the bus. Just a minute, I'll shift it over here. Yeah. So first, physically it is a bus network, but it is a ring network logically. So like it is the principle of the bus network is totally same or based on the ring network. Second, stations are organized as a circular doubly linked list. All the stations are organized as a circular doubly linked list. Third, a distributive polling algorithm is used to avoid bus contention. Fourth, token, the right of access. Fifth, token holder, the station receiving the token. First, The subpoint in this, transmit one or more MAC frame. Second, poll other stations. And third, receive responses. Now moving to frame format. So here's a diagram which shows the frame format. So it is like, firstly preamble comes, then SD, then FC, then DA, then SA, then LSC, then FCS, then ED. So what is preamble? Preamble: establish bit synchronization and locate the first bit of the frame. SD: start delimiter. FC: frame control. DA: destination address. SA: source address. FCS: frame check and sequence. ED: end delimiter. And maximum length from SD, that is the start delimiter, to ED, that is end delimiter, is 8191 bytes. Moving to next slide. So this is also a frame format diagram. So here also we can see there's preamble at very first, then starting with start delimiter, then frame control, then destination address, the source address, then data, then checksum, and then the end delimiter. So here are some basic definitions of the frame data frame format. Preamble: it is used for bit synchronization. It is 1 byte field. Start delimiter: these bits mark the beginning of frame. It is 1 byte field. Frame control: this field specifies the type of frame, data frame, and control frames. It is 1 byte field. Destination address: this field contains the destination address. It is 2 to 6 bytes field. Source address: this field contains the source address. It is 2 to 6 byte field. Data: if 2 byte addresses are used, then the field may be up to 8182, 8182 bytes and 8174 bytes in case of 6 byte addresses. Checksum: the field contains the checksum bit, which is used to detect error in the transmitted data. It is 4 bytes field. End delimiter: this field marks the end of the frame, and it is 1 byte field. So, physical layer of the token bus. The conventional 75 ohm coaxial cable used for the cable TV can be used as the physical layer of the token bus. The difference modulation, the different modulation schemes are used. They are phase continuous frequency shift gain, phase coherent frequency shift gain, and the multi-level duo binary amplitude modulated phase shift gain. Signal speed in the range of 1 Mbps, 5 Mbps, and 10 Mbps are achievable. The physical layer of the token bus is totally incompatible to the IEEE 802.3 standard. So now we come to the MAC sublayer function. First, the token. The token passing is done from high to low address. Second, whenever a station acquires the token, it can transmit frames from a specific amount of time. Third, if a station has no data, it passes the token immediately upon receiving it. Fourth, the token bus defines 4 priority classes: 0, 2, 4, and 6 for traffic, with 0 the highest, the lowest, and 6 as the highest. Next point, each station is internally divided into 4 substations, one at each priority level, that is either 0, 2, 4, and 6. As input comes in to the MAC sublayer from above, The data are checked for priority and routed to one of the four substations. Now moving to the next slide, it is the continuation of the functions. So the first point in the slide is thus each station maintains its own queue of frames to be transmitted. When a token comes into the station over the cable, it is passed internally to the priority 6 substation, which can begin transmitting its frame if it has any. If any frames are present, then only it will begin transmitting, else it will not. Next point, when it is done or when its time expire, the token is passed to the priority 4 substation, which can then transmit frames until its timer expires. After this, the token is then passed internally to priority 2 substation. This process continues until either the priority 0 substation has sent all of the frame or the time expires. After this, the next point is after this, the token is passed to the next station in the ring. So, the token passing bus protocol functions. First, the first point here is ring initialization performed when the network is first powered up and after a catastrophic error. Second, station addition optionally performed when a station holding the token accepts the insertion of new successor station. That is a new station with an address that is between that of the station holding the token and its current successor station. The next point, station removal is achieved by sending new successor identification to its predecessor or by just disconnecting from the LAN. In the later cases, a recovery mechanism established the proper new logical ring configuration. Recovery and management, including recovery from failures such as bus idle, lack of activity on the bus, token passing failure, lack of valid frame transmission, the presence of duplicate token, and detection of station with a faulty receiver. So, now I'm going to tell you the working of the token bus. So, when the network is first powered up or after a catastrophic error, the logical ring needs to be initialized. The idle burst timer expiring in LAN station triggers this process. The detecting station sends a claim token MAC control frame. As described above, each participating station knows the address of predecessor, that is the station that transmitted the token to its successor, and a station to which token should send next. After a station has completed transmitting data frames and has completed other logical rings maintenance functions, the station passes the token to its successor by sending it a token MAC frame. Any failure in reaching a successor station triggers a state's recovery mechanism using other MAC control frames, that is set solitaire 1 and set solitaire 2. If the token holder does not receive a valid token after sending the token the first time, it repeats the token pass operation. If the successor does not transmit after a second token frame, the sender assumes that its successor has failed and sends a who follows the MAC control frame containing its successor's address in the data field. The station detecting a match between its predecessor and the address of who follows, excuse me, who, the station detecting a match between its predecessor and the address in who follows frame data field respond by sending its address in a set successor MAC control frame. In this way, the token holding station establishes a new successor, including the falling station from logical ring. Stations are added to the logical ring through a controlled contention process using response window, a specific interval of the time typical to all stations, and based on numerical address comparisons, the actual procedure referred to as Solid successor procedure. The procedure raises a concern concerning excessive delay experienced by station before gaining access to land when many stations attempt to insert into logical ring and perform the solid successor procedure. The time a station has to wait between successive passes of the token is called token rotation time, that is TRT. To avoid excessive TRT token rotation time, every station measures the rotation time of the token. If the time exceeds a predefined value set by the station management, the station defers initiation of the solid successor procedure and verify at the next appearance of the token whether it is now rotating fast enough to perform the procedure. A station can remove itself from the logical ring only by not responding anymore to the token passed to it. Ring station sequence recovery procedures adjust the successor and predecessor information in the predecessor and successor stations, respectively. A more efficient way of leaving the logical ring is to have the existing station set successor MAC control frame to the predecessor containing the address of successor. Access priority. The token passing bus protocol provides an optional levels priority mechanism by which higher level of data frame, LLC sublayer or higher level protocol are assigned to 8 different service classes according to their design transmission priority. Service classes range from 0, that is low, to 7, that is high. The purpose of this priority mechanism is to allocate bandwidth to the higher priority frames and to send lower priority frames only when there is sufficient bandwidth left. Similarly, each access class is assigned a target from token rotation time, that is TTRT. Each station measures the time it takes the token to circulate the logical ring. If the token returns to a station in less than the token rotation time, the station can transmit more frames until the expiration of TTRT. If the token takes more than TTRT for a specific priority level, no frames of this priority class can send or pass the token. So that's all about the working. Thank you. So this was all about my presentation. Hope you have liked it.